Okay, so we're kind of finishing up on the voting methods and the different ways to calculate which candidate wins an election. And so there's a question on the board account, and students wanted to go over this again. So let's go through the board account method. And with the board account method, it depends on how many candidates you have. And so in this case, we have candidate A, we have candidate B, C, and D. So we have 4 candidates. And so that means that first place winner, so first place votes, get 4 points each. The second place votes, so the number of second place votes that you get for each one, so it's going to be 1 less than how many candidates there are. They're going to get 3 points each. Third, so 1 less than the number of points from the place above. So this would get, third place is going to get 2 points each. And then fourth place votes, they only get 1 point per vote.
So do you just multiply the points by whatever the number of voters there are?
So here, like for voter A, to calculate their votes, let's first look at how many first place votes that they got. And so looking at number of first place votes that A got, well, they only got 7 here, and notice that they didn't get any here. And so for A, they get 7 times, well, though that number of first place votes, that was worth the 4 points. And so that will be the 7 times 4. Plus, and so now we're going to go to the second place votes, and we're just looking at A for now. And so let's just cross out anybody who's not A in the second place. And so notice that they have 4 votes for this, how they ranked it this way, and they had 3 votes here. And so technically they have 7 winners, or 7 votes for second place. So 7 times, but second place, those count only as 3 points each. And then we're going to go to third place, and we're only again looking at A. And so on third place, how many? There's people that voted them here. 3 voted them as their third choice, and no one else. And so here we would have 3 plus times the number it's worth. And third place votes are only worth 2 points, so 3 times 2.
I got a question.
Yeah.
Did you put the number 3 because you had to add the how many 3s there was to that 1? I mean, I'm sorry.
Which 3 are you talking about? The second one, 3 right here?
All the way at the bottom. Is that the last? You know how you just put 7, and then I mean, I'm sorry, 3.
No. 3 and 2.
And then the 12. Yeah. Why did you do that?
Okay, because we're looking at just candidate A and how many third place, how many people rank them candidate A as their third choice. And so if we go through the number of votes and we look at just the third choice, and we would just look at what number A, who ranked A, we don't care about the other candidates at this moment. Notice that 3 people right here voted them. And that's where this 3 comes from. And then this 2 comes from because third place votes only get 2 points, that 3 times 2. And then like the fourth place kind of do the same thing. So all we're doing is we're going to go through all the fourth choice candidates, and we're going to circle A, or just so we can see it. So out of fourth place, notice that A got 4 votes here, plus they got 2 people that voted him fourth place in this, and 1 person here. And so total number of people that ranked A in fourth place is 4 plus 2 is 6 plus 1. So this would equal 7 down here. And so 7 votes times how much fourth place is worth in the voting system. And in this problem, it's only worth 1 point. And so let's go through, and order of operations says you first multiply before you add anything. And so 7 times 4, that's 28. Plus, so basically this is saying they got 28 points for the number of voters that ranked them number 1 in this, plus 21 points for the number of second place, 6. This 2 times 3 is 6, plus 7 times 1, which is 7. So go through and add them. And so 28 plus 21, I'm just going to go left to right, is 49, plus 6 plus 7. And 49 plus 6 is 55, and 55 plus 7 gives us 62. So for the border count, A has 62 points. So you have to go through and do the exact same thing for all the other candidates. So now we're going to go through this preference schedule of how many people voted this preference. And we're going to just look at B. And if you just look at B, so let's look at just the first place. So for B, 4 people voted them first place here. 3 people voted them first place here. 2 people voted them in the first place here. And so if we sum this for B, we have 4 plus 3, which is 7, plus 2, which is 9. So 9 people ranked B as their first choice, and that was worth 4 points. Plus, now you got to go through and now do the exact same thing, but now we got to do it for the second place. And so for second place, we're just looking at B and how many people ranked them second choice. Well, there's only 1 ballot that they ranked B second, and that was 4 people. And so this would be 4 people times third place, or second place is worth 2 points. I'm sorry, second place is worth 3 points. So go to third place. We have 7 people here and 1 person here. And so 8 people ranked candidate B as their third choice. And that one is worth 2 points. So from here, last place, only 3 people ranked them last, which was worth 1 point. So if we go through, 9 times 4, that's 36, plus 4 times 3 is 12, plus 8 times 2 is 16, plus 3 times 1 is 3. So 36 plus 12 is 48, plus 16, plus 2. 48 plus 16 is 64 plus 2. So they got 66 points altogether. And so candidate B, so far, candidate B would win. Does that help? You guys understand now kind of how to do it?
A little bit, but I'm still gonna need a little bit more practice.
Well, we got 2 more. Did I calculate wrong somewhere? 48. B should be 67. 36, 12 is 48. 16. Oops, you're right, because I am right here. 3. It should be plus 3, and I put down plus 2. So this should be 64 plus 3, which you're right, is 67. So you got to go through again at each candidate and do this whole process. So we got to look then at C, and you would go through, you know, and you would say, okay, how many votes are first place for C? Well, C has 4 plus 1, so that's 5 first place votes, which are worth 4 points. I kind of pick up the pace here. Going through on C here for second choice, we have 3 plus 2. So there's 5 people that choose them as their third candidate or second candidate, which is worth 30 points. The third place candidate, they have just 3 votes. So they have 3 votes, but that's worth 2 points each. And then their fourth place candidate, well, 7 voted him fourth place here, plus 4 voted him fourth place here. That's 11 people voting him in fourth place. And that's only worth 1 point. So we have 5 times 4 is 20, plus 5 times 3 is 15, plus 3 times 2 is 6, plus 11 times 1 is 11. So that's 35 plus 6 is, sorry, 35, 41, 41 plus 11, that should give us 52. And so C, there's 52 points. And the last candidate, so we got to count them for D. Oops, that's not an eraser. And so for D, for first place, go through. They have 3 votes here and no other. D's not going to do good. So D, this is equal to 3. All times that was worth 4 points. Plus, so D got 7 here and 1 here. So they have 8 people that thought that they should get ranked him second, which was worth 3 points. D here has 4, plus 4 is 8, plus 2 is 10. So 10 times 2. And then here we have 3, so plus 3 times 1 point. So going through and multiplying and summing, 3 times 4 is 12, plus 8 times 3 is 24, plus 10 times 2 is 20, plus 3 times 1 is 3. So 12 plus 24 is 36. 36 plus 20 is 56, and 56 plus 3 is 59. And so by the border count, you're looking at the person who has the most amount of points. And so by the border count method, we have that B is the winner. Would B had been the winner if we were just looking at plurality? What was plurality? Anyone remember what it meant to count or calculate votes by plurality? So plurality, you're just looking at who has the most, just looking at the first place and who had the most votes for first place. So if we looked at that, would we get the same results as what we just got for the border count? And so for the plurality method, we'll do that in a second, but let's go into my math lab and actually answer this. And let's see what the second question is. It might ask us that. So first question, by the border count method, who is the winner? And we found that it was B. A sigh of relief that we got some positive feedback and it didn't tell us sorry. Okay, so find the complete ranking of the candidates. Choose the correct best answer. So the ranking here is going to be who had the most points, which is B. Then who had the second to most votes? Was it D or A? Let's go back here. So it looks like for me, something's wrong because oh yeah. So it looks like B is first. Something's not wrong. For our ranking, next person who gets the next highest number of votes or points was A, so they should be second. D is third. And C would then be fourth. So B, A, D, C. Okay, so right here, this would be the ranking of our candidates. Okay, so looking at it, going back again, I was saying, let's look at if this was the same person who would have won, candidate who would have won if we just looked at plurality. So the plurality method was looking at who had the most votes, first place votes out of everybody, they should be the winner. And so plurality method, if we looked at this, our first place votes, A has 7. So A is equal to 7. We look at B. B has, well, they have 4 here, and they have 3 here and 2 here.
9.
So 4 plus 3 is 7, plus 2 is 9. So they have 9 first place votes. C, if we go through and look at C, how many first place votes they have 4 plus 1, which is 5. And D, well, they only had 3. So by plurality method, this candidate also wins because they got the most number of first place votes. Was candidate B a majority winner? So what makes that person in a majority? They won by majority.
More than 50%, right?
Yeah, so they have to get more than 50%. So let's look at, first of all, how many people voted. And so if we look at how many people voted altogether,
It's like 24 or something like that.
we got 11, 15, 18, 21. You're right, 23, 24. So half of 24, that would be 12. And that's just 50%. Majority wants more than 50. And so that has to have, majority would have to have 13 votes or more. So it would be a majority winner. If they had 13 votes or more. Okay. How about plurality with elimination? So these, I'm just kind of pulling this in and kind of tying everything that we've kind of looked at so far this semester with the different methods. And that kind of will tie us in with the last portion or last section of this chapter, which is Arrow's Impossible Theorem, or what makes it fair and how we calculate the vote. So fairness criteria that has to happen. And so it kind of looks at all these different methods we're looking at. And so let's look at plurality with elimination. Okay, so what plurality with elimination says, if you look at the first place winner and they didn't get more than 50% of the votes, you're going to go through and you're going to eliminate the person who had the least number of votes from the ballot. And so eliminate the person with the least number of votes, votes start to move up in place. I'm going to just grab this and copy and paste. Okay, so let's look at plurality with elimination. And so we saw that the least number of votes, first place votes, was D. And so we're going to go through and we're going to take D out of this ballot. So if we took D out of this ballot, they no longer got this 3 votes for first place, and everything shifts up. So technically, everything would shift up here. D would go here, so A would shift up. C would shift up. You did that one. Nothing shifts here. A would shift up to third place, and B to second. So we would first eliminate D because they had the least number of points or votes. And then recalculate to see if the winner had majority. So eliminate D. They did someone win by majority then? And if they didn't win by majority after getting rid of D, then we're going to get rid of the candidate with the least number of votes after we shifted everybody up. So let's look at it after we've eliminated D. A has, well, A still has 7 here. They didn't get moved up in here. So A has 7 votes still. B, they have these 4 votes here. C is the one who moved up here. They have 3 votes here and 2 votes here. So 4 plus 3 is 5 plus 2. Is that right? Is 9. So 4 plus 3 is 7 plus 2 is 9. And C, they got 4 votes here. They moved up here, so they got 3 votes here. That's 7. and 1 vote here, which is 8. Okay, so we're still looking at this out of 24 votes. And again, to have majority, they had to have 13 or higher. And so no one became a majority. So there's still no majority. So we want to do this again. And so in this case, we want to eliminate the candidate who has the least number of votes. Looking at 7, 9, and 8, to me, that would be candidate A. So we're going to eliminate candidate. Can't spell now. Okay. So in here, I'm going to go through. If I see A, we're crossing it out. Okay, so we want to look at candidate B. So notice that candidate B on this first column of 7, because we crossed out A and D, candidate B is now first choice. C is still here, B is still here. Here, we had to cross this out. C is now still third choice, B, B, C. Okay, so let's go through and count. First choice for B. We have 7 plus 4 is 11, plus this 3 is 14, plus 14 plus 2 is 16. I can already tell that's more than 24, but let's just go make sure and calculate this, see if my math was right. So 4 plus 3 is 7, 7 plus 1 is 8. This should sum to 24 votes. It does. And so by this method, plurality with elimination, we have that B wins. Okay. What other method have we looked at? Anyone remember that we haven't looked at so far in this example? What other method have we looked at this semester with calculating votes? Anyone know? Okay, so someone stated it. So it was the pairwise comparison, and that's where we had to go through and take our candidate A and compare them to every single other candidate and see if they would have been the winner with that pair, with a pairwise. Whoever wins the most out of the pairs, going through each candidate is the winner of that pairwise. Okay. I'm gonna go back down here, and again, I'm gonna copy and paste. Okay, so let's look at the same ballot, and let's look at this with a pairwise. So use pairwise comparison. To determine the winner. Okay, so I'm just gonna start with candidate A. We have to look at them versus candidate B if they would win. We're gonna have to look at candidate A versus candidate C. We have to look at A versus D. And if they were just matched up with this other candidate, would they win the election or not? And so A and B. So you're gonna go to the first column here where we have 7 votes voted it this way. So you don't care about D and C. You wanna know who would have won out of here if it was just A and B. Well, A obviously has more votes, higher ranking than B. So they would have been the winner just for the people that ranked the candidates in this order. And so here we have, so A is equal to 7. I'm just going to do this on the side for a second. Here, if we look at it on this ballot, B would have been the winner, right? B is above A. So B in this case won, and they got 4 votes. Here, the third choice, where that was B, A, D, C, B is ranked higher than A. And so that was 4 people that voted that way. So let's add it to B. Here, this way, they ranked A higher than B, and that was, I covered it, I think that was 3 votes. Yeah. So that was going towards A, so +3. For this next ballot, B over A, so they get 3 people. Here we have B over A again. That was 2 people for B. And here 1 did B over A. So if we look at the number here, 10 versus 4 plus 4 is 8, plus 3 is 11, plus 2 is 13, plus 1 is 14. So 10 votes, 10 people preferred A over B, and 14 preferred B over A. And so B in this case would win if we were just comparing those two. So go through again. Now we want to look at if it was just A and C in the election and we got rid of the other 2 candidates, who would rank top? Okay, so let's look at A versus C. And so you will cross out D and B in all of these. D and B in all of these. D, B. Okay, so A versus C. So here, I'm just going to go and circle where A wins. So they won here, they won here, they won here. And that's the only time they ranked higher than C. So if we go through and count how many votes they ranked higher than C, so we have 7 plus 4 plus 3, that's 10. So 10 versus, if I count this, the ones that are left, I should get 14 because I know that there's 14 voters. So 4 plus 3 is 7, plus 2, did I miss one? 4, 3, 7. Why is that not working? 9 plus 1. I counted somewhere I counted wrong. So let me go back in. So A would have been 7 plus 4 plus 3. I definitely counted wrong. I don't know where I did that. So 11 plus 3, that's 14. Actually, A would have gotten 14. So A is the winner through that comparison. Same thing, go through now and just have A and D in the election. Get rid of B and see who ranks the highest. So we're getting rid of B and C. BC, BC. Okay, so winner here is A. I'm going to go through again and just circle the A's. Whoever, if they're the top, I'm going to circle it. So they don't win there. A wins here. D wins there. A wins here. D wins here. And D wins here. So if I was calculating where A won, that's 7 plus 4 is 11. 11 plus 3 is 14. So 14 versus, and I'm just going to, again, just to check to make sure my did this right, is that's 4 plus 3 is 7 plus 2 is 9 plus 1. So that's right. Okay. So out of this comparison, A wins. So I still have to match up other candidates. I have to match up B with all the other candidates, but we already really matched up B and A. So it kind of eliminates and we don't have to do as much after we do the first candidate. So B, we need to look at B versus A, which again, we already did. We need to look at B versus B. One color. Not gonna let me do it. Okay, oh well. So we need B versus C, and we need B versus D. So B versus C, I'm going to get rid of A and D. A and D. Oops. A and D. And so by getting rid of A and D, I can see who is on the top of each one of these. Okay, so I'm going to go through and rank or see where B wins. So B wins 7 out of 6. B wins not there. 4 here. Not there. 3 here. 2 here. Not there. Okay, so they won 7, 11, 14, 16. I got 16. 7, 11, 14. So I have 16 votes versus, and I have to see now C. So let's just make sure. So C had 4 here, plus 3 here is 7. 7 plus 1. 7 plus 1 is 8. So B. Do the same thing with B and D. So we're erasing C. I'm just going to erase it all. B wins again.
What numbers are you counting up on this part?
The numbers on the top. And so if they rank the highest in the column, then they got that number in there. And so for instance, for B and D, so if I'm just doing B and D, B in this case is higher than, I'm sorry, D in this case is higher than B. So D wins here. So they get the 7 points or 7 votes. And so to me, it's just kind of easier if I just cross out the ones I'm not looking at and I can see, you know, who is higher on the list. And so here we're getting rid of A and C. We're just doing B and D. A and C. A and C. Okay, so you're looking at who ranks highest. D is higher than B here, so they get 7 points. Let's just do, I guess, D then. So D is ranked higher here, but B is higher than D here. So they are not gonna, B is gonna get the points on there. B is higher than D here, so B is going to get the points above number of votes. D, though, is higher than B. Out of 3 people voted that. B is higher than D here, so B gets those votes. B is higher than D here, so B is going to get those votes. But D is higher than B here, so they get this vote. So D only gets, people that rank D higher than B were 7 plus 3 plus 1. So that's 11 people gave D their preference. So the number of people that gave B their preference in each one of these votes, well, B was a winner here. So 4. B was a winner here, so another 4, that's 8. B was a winner here, that's another 3 people, that's 11 people. And 11, B was a winner here, plus 2 is 13. Again, the sums to 24, all these sum to 24, so I know I didn't miss something. And so B is the winner here. So now I have to look at C versus A, but C versus A is already done. C versus B, already done. So we just have C versus D. So C versus D, you're going to get rid of B and A in all of these. So A and B are gone. And we're just looking who ranks higher out of B, D, and C. A and B are gone. Okay, so I'm going to go through with C first. So looking at the first ranking, D is the winner. Looking at the second ranking, we'd have C as the winner. Third ranking right here, C loses. C loses. Okay, C wins here. C wins here. And I crossed out the wrong thing. So A and B. So looking at it here, C also wins. So they won 4 plus 3, which is 7. 7 plus 2 is 9. 9 plus 1 is 10. So 10 versus D should get 14 votes, but let's just make sure. So we have 7 plus, I did that wrong. I think I did that wrong. Because D was the winner here. Well, that's why I'm going back through. So 7 plus 4 is 11. 11 plus 3 is 14. Okay, I guess I didn't do it wrong. And so D has more votes than C. So we got to go through, and now you got to count how many times did A win a pairwise comparison. So if you go through here, they've only won here and here. So they have only won twice. If we look at B, then here we have that B won once here, and once here. So they've won 3 times. If you look at candidate C, doesn't look like C ever won. And D. So D just won once. So out of the comparison, pairwise comparison, B won the most out of being paired up with others. Did I make any, you guys seeing any errors in there? I see some chats going on. Okay. Okay, so this kind of brings us to the next section, which is pretty fast, which talks about arrows and possible theorem. So this is where I kind of wanted to show you that video. I don't think that that's probably going to work. So I'm going to upload it, but pretty much they're going to kind of say exactly what I'm saying. I just thought that they probably would did a better job than I did or would. And I liked how he did it and the visuals and stuff. So I was going to share that with you, but let's go instead. So basically our question is, out of all those different voting methods that we looked at, is there one that is better than the other? And kind of discussed that a little bit in the last class period. And so if you found that one is better than the other, could you defend your answer? Why? Why do you like that one better? And why do you think that one works the best? And then the next question to kind of just think about and ponder is, what makes a voting system fair? You know. Okay. And so that comes to a huge decision that people have been working on for decades on this, and trying to prove what could make something fair in a voting method or not. And so I just pulled this from the book, and I just kind of want to read through it, and then we'll talk about it. Okay, so far this is what we learned. There are many different types of elections, and there are different ways to decide their outcome. We examined 4 different voting methods in some detail, but there are many others that we don't have time to discuss. Okay, so now comes a different but fundamental question that may have already crossed your mind. Of all voting methods out there, which one is the best? As simple as it sounds, this question has vexed social scientists and mathematicians for centuries. So going back to the Condor set and the border in the mid-1700s, for multi-candidate elections, 3 or more candidates, there is no good answer. In fact, we now know that there are limitations to all voting methods. This is very important and famous discovery known as the Arrow's Impossibility Theorem. So in this section, we're going to discuss the basic ideas behind this theorem. Okay, so in the late 1940s, American economist Kenneth Arrow turned to the question of finding an ideal voting method on its head. And asked himself the following: what would it take for a voting method to at least be a fair voting method? To answer this question, Arrow set forth a minimum set of requirements that we call Arrow's fairness criteria. So in all fairness, Arrow's originally formulation was quite a bit more complicated than this one that we're presenting right now, and this list below is a simplified version. But he's said if a voting met the fairness criteria, this is what has to happen. So the majority criteria. So it says if there is a majority candidate, i.e. the candidate with a majority of first place votes, then that candidate should be the winner of the election. We have the Conducive Criterion. If there is a Conducive candidate, i.e. a candidate who beats each of the other candidates in a pairwise comparison, so that's what we were just looking at, then the candidate should be the winner of the election. We have the Monotonicity Criterion. If the candidate X is the winner of an election, then X would still be the winner had a voter ranked X higher in his preference balance. So in other words, if a voter should not be able to be hurt if the winner hurt the winner by moving her up in his ballot. Because I believe that's like what we were just doing when we were doing the elimination with the plurality. And so if you're moving somebody up in the ballot and they were the winner before, that shouldn't hurt them. The independence of a relevant alternative, which is IIA criterion. If a candidate X is the winner of an election, then X would still be the winner had one or more of the irrelevant alternatives, i.e. losing candidate, was not there in the race. In other words, the winner should not be hurt by the elimination from the election of irrelevant alternatives. Okay, so the above fairness criteria represents some, but not necessarily all, of the basic principles we expect a dramatic election to satisfy, and can be used as a benchmark by which we can measure any voting method. If a method violates any of these criteria, then there is a potential for an unfair result under the method. And so in this section, and we just kind of worked through it today, what you would do is you would have to see, looking at a ballot, would they be the winner if you went through all of these? And if you did, then the election is fair. If one of those things didn't hold, then we would say the election isn't fair and it had to do with this method. And so like in this example, I guess I do have time. So we want to illustrate why the border count method violates the quarter set criterion. Okay, so quarter set says, if there is a quarter set candidate, the candidate has to beat each of the candidate in a pairwise decision, then the candidate should be the winner. So we want to look at both the pairwise comparison. Right, comparison, and look at the border count. So they pretty much basically told us that one of these is not gonna, they're gonna give us a different winner. And so because we get different winner at both of these by this Arrow's Impossible Theorem, this voting method was not, didn't hold. Okay, so you have 4 candidates. That means you got to rank things. Candidates by first place would be 4th, or 4 points. So if we look, second place votes get 3 points. Third, just like we had done before, this one gets 2 points each. And 4th place, you were ranked in 4th place, you only got 1 point for each vote in 4th place. So you have to go through and look at A. So A, just A, ignore the other ones. And so look at A was voted first here. That 6 people voted them first here. So they have 6 times 4. And then 2 people voted them last, plus another 3 people voted them last. So there's 5 people that voted them last. And so that's only worth 1 point for each vote. So 6 times 4 is 24, plus 5, which gives us 29 points. So B. Okay, so B, they got second place here. And so second place, is they get second place anywhere else? Nope. Okay, so second place, they get, that's 6 people, and that's only 3 points. They got first place here, which is 2 people. So 2 people, but that's worth 4 points per vote. And then 3 people here. 3 people voted them third. So 3 people, third place gets 2 points. So 6 times 3 is 18, plus 2 times 4 is 8, plus 6. 8 plus 18 is 26, plus 6 is 32. So go through, just look at C. So C. So C gets 6 votes for third place. So 6 times third place is worth 2 points. Plus, they got second place. 2 people said second place, which is 3 points. Plus 3 people said first place candidate, which is worth 4 points. So we got 6 times 2 is 12, plus 2 times 3 is 6, plus 3 times 4 is 12. 12 plus 12 is 24, plus 6 is 30. So they got 30 points altogether. D. Last place there, second to last there, second place here. So 6 people ranked them last, which is only 1 point per vote, plus 2 people ranked them third place, which is 2 points per vote, plus 3 people voted them second place, which is 3 points for the vote. So we got 6 plus 4 plus 9. That's 19. So they get 19 points. And so by the board account, B would be the winner because they have the most. Okay, so now we got to look at the pairwise comparison. Again, that's where you're going to have to do A versus B, A versus C, A versus D, B versus C, B versus D, and C versus D. So if it was just A and B together, who would win? Who ranks higher in each of the categories? Okay, so if I was just looking at A and B, A wins here, B would win here, and B would win here. So looking at this, 6 versus 5. So A wins this match. So now we'll go in and look at A and C. Okay, so A beats C here. A versus C. C versus beats A here, and C beats A there. And so 6 for A and 5 for C. So A wins. A beats D in the first one. D beats here, and D beats here. And so again, it's 6 versus 5. A is the winner. So now look at B. We're looking at B versus C. So B beats C here. B beats C here, but C beats B there. So B wins 6 plus 2, 8 people rank B higher than C, and 3 people vote C higher than B. B and D. B wins, B wins, D wins. So same thing. 6 plus 2, 8 versus 3. And then C versus D. So C wins in the first column, they're higher. C wins in the second column because they're higher than D, and C wins in the third. And so C here wins all of the votes, 11 votes. They got 0, and so C wins. But out of the pairwise comparison, A wins 3 of the times, B wins 2 of the times, and C wins 1 of the time, and D wins 0. Okay, so from this, the Condorcet winner is A. And so we just showed that this violates the fairness criterion. So pretty much just this section, I don't think there's very much problems in the homework. You're just doing what you had been doing the whole time in all of these sections, and it's probably going to tell you compare, using this method and this method, and show that the fairness criteria isn't met. And so you're going to show that it's not being met because you're getting a different result depending on which method you're using to calculate the winner. Okay, so we finished chapter 1, and did I miss something up there? I don't know when you guys said that, so let me just stop.